now that you've done 3.5 and you think that matrices are really easy to deal with, I have to burst your bubble. So now we are doing multiplying matrices. Now this is something that takes practice. It is something that takes some work. This is actually something that I never got when I was in Algebra 2. I did not do so well on that test. So if you get this, you're smarter than the teacher. This is something that is a bit tricky to kind of really grasp how exactly it works. So when we are multiplying matrices, it is not just as simple as addition, where we would say if we were to just multiply A times E and then have that be the new top left number, and then multiply B times F and have that be the new top right number. It is not that simple. So what we have to do instead, and the reason why we do this this way is because doing the matrix multiplication this way allows us to do so much more with the matrices than we would otherwise be able to do. We'll get to why that is later. But for now, let's just look at how exactly to do it. So the main thing to remember is that in the matrix on the left, you're going to go across rows. So you're going to go like this. And in the matrix on the right, you're going to go down columns. So you go across the row on the left while you go down the column on the right. So for our top left number, what we do is we take A and multiply it by E. So the top left times the top left, multiply those together, you get AE. And then you add to that the next one in the row and in the column that you're going down. So the matrix on the left, the next number is B. So we multiply B times the next number down in the other matrix. We get G. Multiply those together and then add that to the first one from A and E. So we take the top left and top left, multiply those together, and then add to that. In the matrix on the right, you move to the right. I'm sorry, in the matrix on the left, you move to the right, and on the matrix on the right, you move down. And then we keep doing this. So for the next one, what we're going to do, for the new top right number, we're going to, so the top right number, this is in the top row in the right column, so we use the top row and the right column. So we do A times F plus B times H. And you continue on doing that, and the place where this is in the matrix tells you which row and which column you use. So if you're, say, looking at the new bottom left spot, you're going to use the bottom row and the left column. If you're trying to look at the new bottom right spot, you're going to use the bottom row and the right column. Okay, now before we actually get into multiplying actual matrices with actual numbers, let's talk a little bit about whether or not the multiplication is going to be defined. So what this means is that we can't actually have matrices that are not defined, which means we can't do that, multiplication of matrices that is not defined, which means we can't do that multiplication. So since, as you can see, we're going across rows as we go down columns, that means that the number of rows in the first matrix has to match the number of columns in the second matrix. If it doesn't, then we can't do it. So if, say, matrix A is an m by n matrix, where m is the number of rows and n is the number of columns, I might have said that earlier. The number of columns in the first one needs to match the number of rows in the second one. In any case, the second letter here, that's the number of columns. So that has to match the number of rows in the next one. If it doesn't, so if these two are not the same number, that's why they're both an n there. If they're not the same number, we cannot do multiplication with it. It's impossible to do that. And then the resulting matrix is going to take on the number of rows from the first one and the number of columns from the second one. All right, so before we, again, do any actual matrix multiplication, let's just look at matrices. Say one of them is a 3 by 2, and one of them is a 1 by 3. Well, these two, these two numbers here, these are not the same. So the number of columns in the first one does not match the number of rows in the second one. And so we can't actually do that. So no, it is not defined. For the second one here, matrix A is 5 by 2, matrix B is 2 by 3. So since these are both 2, since the number of columns in the first one matches the number of rows in the second one, we can do this matrix multiplication, and the resulting matrix will take on, again, the number of rows from the first one and the number of columns from the second one. So the resulting matrix will be a 5 by 2 matrix. For the next one here, 3 and 4 here are not the same. We cannot do this one is not defined. So the number of the number of columns in the first one does not match the number of rows in the second one, so we cannot do that multiplication. The next one is a bit interesting because you see they're both 3 by 2. So you'd think that you could multiply two matrices if they have the same dimensions, but that is not the case. So the number of columns in this one does not match the number of rows in matrix B. So that one is not defined. We can't do that. For the second to last one, we've got two columns in the first one, 2 rows in the second one. We can do that. And again, the resulting matrix will take on the number of rows from the first one and the number of columns from the second one. So the resulting matrix will be an 18 by 18. And 3 by 3 multiplied by 3 by 3. Well, again, number of columns in the first one matches the number of rows in the second one. So we can do this. And the resulting matrix will take on the number of rows from the first one, and the number of columns from the second one will be left with the 3 by 3. All right, now let's actually start trying to do this. So looking at these two matrices, the first one is a 3 by 2. The second one is a 2 by 3. So again, number of rows first, rows are horizontal, then number of columns second, columns are vertical. All right, so looking at these, the first one has 2 columns, and the second one has 2 rows. So we can do this matrix multiplication. And the resulting matrix is going to be a 3 by 3. Okay, so when we draw this, I'm going to just put blanks here for each spot. So we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, and I guess I'm going to have to extend this a little bit. Okay, so we're going to have a matrix that looks kind of like that. Now, for the first spot, this spot here, this is in the top row, and it's in the left column. So that means we're going to use the top row of the first matrix and the left column of the second matrix. So again, what we do is we take the first one in the first row and the first one in the second column, multiply those together. So 3 times 1, that's going to be 3. Then we add to that the second number, so we go to the right across this column, and then we go down, sorry, I said that wrong. We go right across the row, down across the column. 2 times 7 is 14. So we get 3 plus 14 there. 3 plus 14 is 17. So 17 is the new number in the top left of the matrix. All right, let's look at the second spot. So this spot right here, this is in the top row and the middle column. So we're going to use the top row of the first matrix and the middle column of the second matrix. Now, we start with the first one in each row in each column, multiply those. 1 times 4 is 4. Then we add to that, we go across the row and down the column. 2 times 8 is 16. Add those together and we get 20 for the new number in the middle. On the top right, let's see, this one here is in the top row and the right column. So that means we're going to use the top row of the first matrix and the right column of the second matrix. So again, multiply the first one in each together. 1 times 7 is 7. Then add to that the second one in each. 2 times 8 is 16. Add those together, and you get 23. Now, I am going to go through this entire matrix, but if at any point you feel like you've got an understanding of how this works, feel free to skip ahead. Okay, this one here. This is in the middle row and the left column. So we're going to use the middle row from the left one and the left column from the matrix on the right. So first spot of each, 3 times 3, that's 9. Add to that the second spot of each, 4 times 7, that's 28. Add those together, and we get 37. Now for this spot here, this is in the middle row, middle column. So we're going to use the middle row of the first one and the middle column of the second one. First one in each row and column is 3 and 4. Multiply those together to get 12. Then add to that the second one of each, 4 and 8. 4 times 8 is 32. Add those together and we're going to get 44. This spot here, this is in the, let's see, it's in the middle row and the right column. So on our original matrices, we're going to use the middle row and then the right column. Do the first times first. 3 times 7 is 21. Add to that the second one times the second one. So 4 times 8. 4 times 8 is 32. Add those together and we get 53. And for the last row. So this last spot is in the bottom row and the left column. So when we multiply these, we're going to use the bottom row and we're going to use the left column. 5 times 3 is 15. Add to that the second one of each, 6 times 7, that is 42. Add those together, and you get 57. 2 more. This spot here, this is in the bottom row and the middle column. So when we multiply, we use the bottom row and middle column. First spot in each, 5 and 4, multiply those together to get 20. Then we add to that the second spot of each, so 6 and 8. 6 times 8 is 48. Add those together and we get 68. All right, last one. This one is in the bottom row and the right column. So when we multiply, we use the bottom row and the right column. 5 times 7 is 35. Then the second spot of each, 6 times 8 is 48. Add those together and we get 83. So in the bottom right of the screen there, that is the resulting matrix. Okay, we're only going to do one more because these do take a bit of time. But let's take a look at this. So the first matrix here is it's a 2 by 3. 2 rows, 3 columns. And we're multiplying that by a matrix that has 3 rows and 1 column. So we can multiply these together because the number of the number of columns from the first one matches the number of rows from the second one. So we can multiply them together. The resulting matrix will take on the number of rows from the first one and the number of columns from the second one. So we're only going to have a 2 by 1 matrix when we multiply these together. So it's going to look something like this. That's it, just those 2 spots. All right, so let's start multiplying these together. Actually, I'm probably going to have to give myself some more room here. So the first spot is in the top row and the only column. So we're going to use the top row and the only column. So then the first spot of each, 1 times 9, that's 9. Then we're going to add to that second spot of each, 2 times 8 is 16. Then we add to that the third spot of each, 3 times 7 is 21. And if we add all those together, we're going to get 46. So we get 46 for the top number. And then for the bottom number, well, this is, let's see, it is in the second row and the only column. So we're going to use the second row and the only column. So 4 times 9, first spot of each, 4 times 9 is 36. Add to that the second spot of each. 5 times 8 is 40. Add to that the third spot of each multiplied. 6 times 7, that's 42. Add up those three, and we get 118. And that right there is the resulting matrix.